Hello everyone, myself Dr. Sarita Yadav, Assistant Professor, Department of Pharmacy, MLN Medical College, Prayagraj, UP, India, as a part of FDP program organized by MCOP Pune and APTI. I am here to give presentation on the topic Introduction to Particle Size Reduction. Now what will you get to learn from this presentation? The important points are the definition of particle size reduction, its objectives or advantages, factors affecting size reduction, mechanisms of size reduction, the summary of different size reduction equipments, and what are the important applications of size reduction. First, we need to understand the definition of size reduction. Particle size reduction is a unit operation wherein materials are reduced to smaller pieces or to coarse particle or to powder. Comminution is an alternative term used for size reduction. It is derived from Latin word minore, which means less. In the figure, we can see that how the reduction of the size of bulk material to smaller particle increases the surface area. An important point to remember is that smaller is the particle, higher is the surface area we can achieve. Before moving further, the most obvious question which arises in the mind of viewers is why size reduction is so important. For answer, I suggest please recall everything you use in your day-to-day life and at what size you are using it. Please think and observe around yourself. The importance of particle size reduction in pharmaceuticals, you will get the answer if you watch out the next coming slides. The answer of the previous question resides in the objectives or advantages of particle size reduction, which includes, as it is evident from the term size reduction, our ultimate aim is to produce smaller particles. And these smaller particles will automatically increase the surface area of particles as discussed. Higher surface area is required for improving the absorption, dissolution process of drugs. Next point is smaller particles are also essential for proper mix or homogeneous mixing of powders, and they are also important for making uniform formulations. Further, handling and transportation of smaller particles or substances is more easier as compared to bulk products or bigger ones. Smaller particles or powders are important for the formulation of stable pharmaceutical dispersions, including suspensions. They are also advantageous for improving the flow of powder, to improve the physical stability of formulation, to improve the dissolution rate of powders, to improve the rate of absorption and adsorption of drugs, to improve the extraction process. Because of all these advantages or objective, we need to have an elaborated study of particle size reduction. There are many factors which affect the size reduction process. They are material properties and equipment properties. In material properties, the hardness of the material, its toughness, abrasiveness, stickiness, softening temperature, material structure, moisture content, physiological effect or potency, and bulk density are the main factors which affect the size reduction process. While in case of equipment properties, the type of equipment, mechanism used, the required size of the particles, the purity requirements, the ratio of feed size to the product size affect the particle size. Now coming to the different mechanism of size reduction, the first mechanism is cutting, in which the material is cut into small pieces with the help of sharp blade or knife or scissor. As we can see in the figure, a sharp blade or knife is cutting the particle. The most important cutter mill works on the principle of cutting. The next process of particle size reduction is compression. In compression, the material is crushed by the application of pressure. As we can see in the figure, the pressure is applied on the particles to be reduced into smaller size by the two surfaces up and down. The example from day-to-day life includes nutcrackers, and in pharmaceuticals, mortar and pestle or roller mill works on the principle of compression. Next mechanism of particle size reduction is impact, wherein the material is stationary and hit by a moving object at high speed or when a moving particle strikes a stationary object. As we can see that in the figure, a hammer is striking on the stationary object, while in case of second part of the figure, the surface is stationary while the object is moving. In the both cases, the impact will work for the particle size reduction. The examples of impact process are, in case of day-to-day life, we already use hammer, and for in case of pharmaceuticals we are using hammer mill. The next process is attrition. In case of attrition mechanism, the pressure is applied as in compression in such a way that both the surfaces are in motion relative to each other, which applies shear forces leading to size reduction. As we can see in the figure, there is both compression pressure is also there, and the shear forces, the both the surfaces up and down are moving relative to the object. The examples from day-to-day life are the files we use, or in pharmaceutical we use roller mill, fluid energy mill. This slide gives a summary of size reduction equipments and their mechanism of action, yielding product size, and the products they are used for and the products they are not used for. As we can see in the table, cutter mill, which works on the principle of cutting, produces a particle size in the range of 20 to 80 mesh. It is used for mostly for fibrous animal and vegetable drugs, example rhubarb, but it is not suitable for friable drugs. We can see that the mills or the equipments acting on the principle or mechanism of impact and attrition are yielding smaller particles as compared to others. The fluid energy mill, which works on the principle of impact and attrition, produces particle size range of 1 to 30 microns, which are very fine particles, and this mill is suitable for moderately hard and friable drugs. But the disadvantage of this mill is that it is not suitable for soft and sticky materials. So from this chart or the table, we can judge which mill is suitable for what type of drug, and accordingly we can use. Now coming to the applications of particle size reduction, which includes formulation of oral powders, dusting powders, suspensions, solutions, granulations during tablets and capsule manufacturing, for extraction of harder drugs like licorice or belladonna, for improving the absorptive power of drugs by increasing their surface area. Also, it has great utility in drug delivery applications, especially for formulation of microparticles and nanoparticles. Thank you, friends, for patiently listening to me. I hope you have liked this presentation. If you have any query, kindly post in the comment box. Thank you.